welcome to our video. This is gonna be great as a test, but it's also gonna be YouTube. So enjoy the video, and I'm gonna give the word to my partner, Adam Sun. Enjoy.
Hello. Guys, today I'm going to explain what will happen when acidic and basic pollutants get into a lake or stream. First of all, to understand this kind of topics, we need to know what is pH and pOH. Everybody basically know what pH is, but if you don't know, well, listen to it right now. pH is basically a scale used to test how acidic or basic a water solution is. It has a scale as numbers from 0 to 14. And pure water usually have a pH of 7, which means 7 is basically neutral. If something is lower than 7, then it is acidic, and if it's higher than 7, then it is a basic. pOH is basically the same thing as pH. To calculate pOH, all you need to do is just 14 minus the pH number. Okay, now after we know what is pH, we can discuss what will happen if the water gets polluted. If strong acidic pollutants such as acid rain or hydrochloric acid, basically it's HCl, get into a lake stream, it will cause reactions such as HCl plus H2O equals to H3O plus Cl. The H ion from acid will come to water molecules to form H3O, raising the concentration of the hydrogen ion. And the resulting large concentration of hydrogen ion makes the solution more acidic and basically leads to a drop in the pH and increase in pOH. While at pH 5, fish eggs cannot hatch. If pH gets lower, the fish will die. Even though the fish can tolerate the acidic water, the animals it eats cannot. For example, frogs have pH around 4, but the flies they eat are sensitive and cannot survive pH below 5.5. It will basically destroy the whole system and many animals will die. If strong basic pollutants such as potassium hydroxide, which is KOH, gets into a lake stream, it will cause reaction like KOH plus water equals to OH plus K. The resulting of large concentration of OH minus makes the solution more basic and leads to an increase in the pH and decrease in pOH. As the concentration of OH ions goes up, the concentration of H ions goes down. And as the hydroxide level increase the pH, algal blooms and eutrophications will occur. The water will become basically all green and all dirty. The water will be undrinkable, and the animals living in the lake will basically all die. Second part, we'll leave it to my partner.
Thank you, Adam, for defining those words. Now it's my turn. Today I'm gonna define the words bronzolori, weak acid, weak base, indicator, buffer, and equilibrium. A weak acid is an acid that doesn't produce many hydrogen ions when in an aqueous solution. Weak acids have relatively low pH values and are used to neutralize strong bases. Examples of weak acids are acetic acid, phosphoric acid, citric acid, and lactic acid. Or you can call acetic acid, it's known as a household vinegar. Let's get to the weak base. A weak base is a base that upon the dissolution in water does not dissociate completely, and the resulting aqueous solution contains hydroxide ions and the concerned basic radical in a small proportion. Indicators are really useful in our everyday life for most people when they want to test some stuff. For example, we can use a Buret test or the Buret reagent to test for protein in a solution. For example, we can add the Buret reagent to the solution and the solution that contains proteins, and it will turn a certain color when it contains proteins. Buret reagent is an aqueous solution of potassium sodium tetrate treated with cupric sulfate and sodium hydroxide. In the Okay, now let's get to the next word, buffer. A buffer is a solution that can resist pH change upon the addition of an acidic or basic component. It is able to neutralize small amounts of acid or base, thus maintaining the pH of the solution relatively stable. We can connect the buffer example definition to a real life uh, word, which is blood, because our blood contains carbonate or bicarbonate buffer that keeps our pH close to 7.4. And enzyme activity depends on the pH. And thanks to that buffer bicarbonate slash carbonate, we can have reactions happening. So because our body depends on reactions slash enzymes. Okay, now that we're done with that, let's define the word equilibrium. An equilibrium is a is when there's a maintaining stable balance in the solution or the solution. Or that means solution or formula. Another word we can define is Bronsted-Lowry. Bronsted-Lowry is a protein theory of acids and bases, a theory introduced by the Danish chemist Johannes Nicholas Bronsted and the English chemist Thomas Martin Lowry, stating that any compound that can transfer a proton to any compound is an acid, and the compound that accepts the proton is a base. A proton is a nuclear particle with a unit positive electric charge. It is represented by the symbol H plus because it constitutes the nucleus of the hydrogen atoms. Um, when chemicals get released into our environment, and it touches our skin and enters our body, harmful stuff can happen. One of those chemicals is known as chloroform. Chloroform, when ingested into our body, inhaled or contacted with our skin, can cause liver damage, kidney damage, brain damage, heart damage, and bone marrow damage. It can also cause hepatitis. Uh, it causes respiratory injuries. Include respiratory depression and pulmonary edema. Uh, these kind of chemicals are also really dangerous to babies or fetuses in their early stages because they're still developing and their immune system is not strong enough to fight against dangerous chemicals. Another chemical I can give an example of is benzene, or known as C6H6, carbon 6, a hydrogen 6. When released into our wildlife, when contacting with air, with the chemicals in the air, it turns into smog. And when it goes down in the ground, it absorbs into our water and our soil. And why that's dangerous is because we drink the water that the benzene was absorbed, and benzene was released because of our activities. Um, we Another chemical we can define is toluene. Toluene evaporates and then gets exposed to the air. When exposed to the air and water, the bacteria starts breaking it down, and it has short-term aquatic wildlife damage. Um, Chemicals are really not good because they can cause a lot of harm to our environment, and we should stop. We should try to help other stuff and organizations to prevent these chemicals from getting released into the environment, and we should may think of a way how to put all these harmful chemicals into special containers, or may maintain them in special environments instead of just throwing them into our air and waters, and then it will affect us back somewhere in the future. Thank you for watching our presentation slash video, and I hope you have a good day. Stay safe, and thank you. Bye.